Hey everyone, good morning. I hope that you are having a good Monday so far. Really excited about today's podcast. We're going to wait just a few minutes for those who would join us online. We got a good one planned for you today. I'm very excited about this podcast. People are enjoying it. Some people are saying they're making it a part of their morning routine. Says that we're live. Let's make sure that we have good audio this morning. Enjoying it. Some people are saying they're making it a part of their morning routine. That's good. Hit that thumbs up button for me if you will. And we'll wait just a minute here and get started. Hope you guys had a restful weekend. It's good to get a little rest, get away from it for a minute. Usually by Monday, I am chomping at the bit. I wake up just shaking with excitement, ready to go back to work. And that's what's good about taking a day in the week, taking some time, getting away from it, and then coming back stronger than ever, hopefully, right? I've lived those seasons where you just scrape up enough energy to do it again and do it again and do it again. And eventually you get where you want to go, hopefully. So that's the game plan, right? All right, let's go ahead and do it. Hey, everyone, welcome back. I am the Electrical Code Coach from electricalexamcoach.com. And this is the Alpha Phase Podcast. And our goal is to be the number one in adding value to you. We want to motivate. I like that. We want to motivate, educate, and inspire. Let's get to it. Today, we're going to take a look at this month in history. This month in history today is good. I'm excited about it. The Great Geomagnetic Electrical Storm of 1882. On November 17th, 1882, a dramatic geomagnetic storm struck Earth, creating spectacular auroras and high-induced currents which severely disrupted telegraph and telephone systems. Reports at the time describe telegraph wires useless for several hours, buzzing and ringing, telephone lines, even equipment igniting in the Western Union offices. From an electrical system standpoint, it was a stark early example of how natural phenomena can trigger major disturbances in human infrastructure. For electricians and inspectors who focus on reliability, grounding, surge protection, shielding, this event especially will resonate. It says your wires aren't just vulnerable to human misuse and overloading and overcurrent and surges and all these different things. The sun can actually reach into our system too. That storm also helps spur a deeper understanding of solar terrestrial interactions. In November of any year, it's worth pausing to reflect on the skies above and the ground below, that they are a part of the same electrical domain that we work in. Now let's talk about the first long-distance hydroelectric transmission. This is really a pivotal moment in human history. Let's dive in. On November 16th, 1896, electricity generated at Niagara Falls was transmitted over 20 miles to Buffalo, New York, the first long-distance hydroelectric AC transmission at this type of scale. It's an amazing story. If you've never heard it, they take and they core directly through that thing, carve out this area, set these generators, the turbines up, the whole 9 yards, build these things. You would have had Nikola Tesla there. You would have had Westinghouse there in person, helping, shaping, crafting, building these giant polyphase generators, and then transmissioning it, getting the wire out of there, and then shipping it all the way to Buffalo, New York. It's exciting. This was a watershed moment. The era of the local generator and for local load was giving way, the era of local generator for local load was giving way to regional grids, long haul lines, and the infrastructure of modern power systems. The impact on the electrical trades was massive. Different standards, transformers, transmission, engineering, safety concerns, insulation, aging, all becoming elevated issues. Because when we stepped up that voltage, it's going to affect the copper differently, later aluminum differently. It's going to affect the outside insulation differently, all of the components differently. They were all used to doing lower voltage DC systems, very short range. So they had to kind of quickly retool literally overnight to go from DC into AC. For electrical inspectors today and electricians, the legacy includes high voltage clearances, transmission corridor inspections, transformer maintenance, and grid resilience, all rooted in that pioneering project. The yellow glow of the streetcar in Buffalo that night wasn't just light. It said, "This system scales." And in November, we mark not just the birth of lighting something, but moving power something farther. It's a reminder that distance matters, infrastructure matters. And we live on the backbone of all of the hard work of the men and women over hundreds of years. And that's why I'm so excited about the era that we live in. We personally didn't build the power lines, the internet infrastructure, the roads that we drive on, and we get to piggyback on this and then insert all of the new technologies. It is a very exciting time to be alive and to be in the electrical industry. Now let's take a look at the code of the day. And today I want to talk a little bit about objectional current. Let's look at the code language, then we'll talk about what objectional current is, what it isn't, and we're going to look at part C here as well and look at an addition in the 2023 NEC, which I was very fond of. This is the paraphrase code language in 250.6. Arrangement to prevent objectionable current. Well, first let's talk about what objectionable current is. It is, and you can find, I could not find an Article 100 definition. You may see a public input from me of what it is. We can't talk about it. We can't have codes about it if we can't go to a dictionary and look it up, and if we can't go to the NEC, look it up. It's just my thoughts on that. But I have limited knowledge of what the code making panel's concept of this is. So don't take that out of context. But objectionable current, it's not just any current flowing on an unintended path, because we have a few definitions for that. Sometimes it's a short circuit, sometimes it's a ground fault, but sometimes it's objectionable current. So I want you to think about it as unintended neutral current flowing on an unintended path coming back to the source, past that point where we intentionally connect the grounded conductor and the grounding electrode system together. So it's current after that fact. And I'm going to do a very simplified illustration for us today. So let's imagine we have a meter disconnect combo outside of the house, and there we connect our grounded conductor, which is our neutral, and our grounding electrode system at that point. Then imagine, let's feed a 4-wire going inside to the house, and we have our indoor load distribution there for the rest of this house. And we run 4 wires over to here, inside on this indoor panel. Now on this indoor panel, let's imagine, let me see if I can get my video a little bit larger here so we can maybe connect a little bit better. All right. Now let's imagine on this indoor panel that we don't separate the grounds and neutrals. Somebody leaves the main bonding screw in and all of the bars are connected. Well, current's going to take any and all paths back to the source. We used to hear it would take the path of least resistance. That is correct in a sense where the lion's share may flow, but in reality, it's going to take any and all paths back to the source. So I ran 4 wires into this main sub panel, we're going to call it for this illustration, but I didn't separate grounds and neutrals. Now some current is not flowing back on the neutral conductor. It's actually also flowing back on that insulated, and it may not be insulated, it can be uninsulated. It's flowing back on that green wire for this simple illustration. So I've got the current coming in, going out and doing work, light bulbs, TVs, everything else. Then it comes back to the distribution panel that it left from. It needs to get back to the source. Some of it's going to ride on the neutral, and some of it is going to ride on the ground. That current that is flowing on the ground is objectionable current. That's the current that we have to arrange our system to prevent it. So anytime that neutral current is flowing on unintended paths back to the source, in an area that it's not okay to do it, and I'll explain what that means here in a moment, that's what it's calling here objectionable current. I've got a video called When and Why to Separate Grounds and Neutrals. Go check it out. It explains it in great detail. Now let's go ahead and take a look at the code language here, and let's talk about it. Grounding and bonding for electrical systems, circuit conductors, surge protectors, and metal parts that don't normally carry current must be installed in a way that prevents unwanted or stray current from flowing where it shouldn't. And this is paraphrased language. You can check out your book. So we've got to arrange the fittings, the wires, the bonding, the connections in a way that won't allow this type of current to flow. I love it. It's excellent. Let's separate grounds and neutrals is the easy way to explain it. Any point past that first point of connection or anywhere else in the system past the point where the code doesn't require us to make it, like if we set another transformer or other parts of the system. But for a simple house illustration, we connect the grounds and neutrals at one point. We never let them touch anywhere else. That includes like a neutral to frame connection on a dryer if it's a 4-wire, a neutral to frame connection on a range if it's a 4-wire, or connecting the neutral to any other non-normally current carrying parts anywhere in the system. So we have to arrange it so it won't do that. That's where you get the code requirement to separate grounds and neutrals. It doesn't just come out and say it, but it tells you, hey, you've got to arrange it so this won't happen. This objectionable current won't happen. Now let's talk about a part that was added in the 2023, I believe it was. And I'm going to try to blow this up a little bit. We might have to shrink it back down so you can read it. Currents resulting from, let me get this out of the way. Boom. Currents resulting from currents resulting from abnormal conditions such as ground faults and currents resulting from grounding connections and bonding connections shall not be classified as objectionable current for the purpose of parts A and B. So what it's saying, and let me break this down simple. Have you ever built like a 400 or 600 amp meter bank and the utility wanted to put a disconnect switch before it? Before the entire system, they wanted to put a meter disconnect. Well, at this one, I've connected my system bonding jumper, and I'm not going to break down what it's called at each location, but I bond for the simple illustration today. I bonded grounds and neutrals at several locations, and let's say in this scenario, I do have metal nipples in between. Well, we know, and the code required me to make these connections, we know for certain that there's going to be some objectionable current flowing on this equipment, these metal nipples, and other conductors. We know it, right? And it should be measurable current. Now, how much? It does, that's up for debate. We would have to measure it. Is it at 0 volts? Yes, it's at 0 volts as long as that neutral is connected from the utility. Not going to get into that part of the illustration today. But it's at 0 volts flowing back. We've racked all these panels. We have 3 disconnects here essentially. The code required us to connect the neutrals and grounds at several different locations. And the question is, haven't I just intentionally created objectionable current? And the answer is yes. It's saying for these type connections that are code required for parts A and parts B, we're not going to get into the whole thing, that is not considered objectionable current. Yes, we know that it's technically created it. There's really no way around it. We need these neutral and ground connections at these points for specific reasons in the system, and those do not count as objectionable current. Then the other one that it says is not objectionable current is currents resulting from abnormal conditions such as ground faults. In the event of a ground fault, first off, all bonding and grounding connections, a part of the grounding system, are supposed to be non-normally current carrying parts, meaning under normal circumstances, these don't carry current. We arrange it in a way that current doesn't normally flow back on a bare ground, right? Or on a metal pipe. It's saying that in the event of a ground fault, an accidental, unintentional connection to one of these grounded parts, that short burst of current, which what should be short if the system's set up correctly, that's not considered objectionable current either. So keep that in mind. We're supposed to arrange our system in a way that doesn't cause objectionable current. It's very dangerous, and let me explain why it's dangerous. I want to blow this up so I can look at you. Listen to me. Let's imagine for just a second I have got this outdoor disconnect and I bond my grounds and neutrals. I come inside with a metal nipple and I go to that first panel and I only run 3 wires, or I run 4 wires and I still connect my grounds and neutrals. So I've got the outdoor panel, I've got my indoor panel, and I've got a metal nipple in between. And I'm using a very simple illustration so you'll understand the danger. All right. I connect these connections here in this sub panel. Current goes out and does its work, and then objectionable current is flowing back on any and all paths back to the source. In this case, we're going to say it's going to flow on the 4 wire, the green wire, and it's also going to flow on that metal nipple. Well, at that point, it is at 0 volts. But let's imagine that a tree falls and it knocks down the power line and it knocks down just the neutral. This happens. The neutral becomes compromised from the transformer, from the utility. If that neutral becomes compromised, that current is still flowing into that house. It's still going out and wanting to do the work, but the light bulb's not going to turn on. All of those wires now become hot because I've disconnected the source, the connection back to the source. And then that pipe and the metal components inside of that panel, all the way coming back to the outdoor enclosure, they're now going to have standing voltage on them. If the grounding electrode system is robust, some of the current is going to want to flow back likely to the utility. But I'm not going to count on, and let's, for this illustration, remove the grounding electrode system. Let's say you had an old ground and it was just a bad ground, and let's just say for this illustration it was disconnected so you can understand what's going on. Let's imagine that there's no ground rod on the house or it's compromised. So the current comes in from the transformer, goes out and wants to do it work, but the light bulb doesn't turn on, so you don't know that there's a danger. That current will actually flow all the way back on any and all paths back to the original distribution panel. Then going back to the source, it's going to take any and all paths trying to get back to the transformer. And in a sense, it's not flowing at this point, but it's standing at 120 volts potential. So that pipe is going to have 120 volts on it, or some type of voltage. And also that the metal panel that you bonded is going to have voltage on it, and the outdoor panel is going to have voltage on it, and potentially, or the neutral wire going all the way up to the weather head is going to have voltage on it, and it can have voltage all the way back to wherever the disconnection point was. So what happens is that when that current is no longer flowing, it's just potential current. But if you're still pumping if you still have the voltage standing on it there, and now you've disconnected the neutral, the light bulb will turn off, but you'll now have that 120 volts in your hand. And I'm going to give another very simple illustration to show you what this is. I can take a light bulb. Let's take an old incandescent light bulb and screw it in. Coming out from my 20 amp breaker, it goes up the resistant element, it comes back on the neutral, and as long as that neutral is connected, that light bulb will stay on until that element burns out. But the moment that I remove that neutral from the neutral bar, but I keep the hot on the breaker, that light bulb will turn off. But now that 120 volts travels all the way through, all the way up the resistive element, and all the way back. And in my hand, I will have 120 volts standing on that neutral wire. It's no longer a neutral, it's now a hot. And if I were to connect a load, another light bulb in between it and the source, then the light bulb will actually turn back on. Both of them would in that case. And the reason I want you to start understanding this is the reason we never start taking neutrals off of a neutral bar, and the reason that you can't double tap neutrals is for this simple fact, is the moment that you remove a neutral that's under load, it now has that voltage standing on it. If there is sensitive electronic equipment in that circuit, it can fry that sensitive electronic equipment. That's why you never open up a set of neutral bundles inside of a switch bank. Because yes, your circuit might be off, or you have to be careful doing it, right? You never work on it live, because if you open up a bundle of neutrals, you might have 4 that are now dead, but you've now got 1 that's hot. Because when you removed its path, or you might end up with 4 that's hot and you've got 1 of them that's dead, right? The one going back to the source is now dead, but if you've got 5 neutrals in that bundle, you could potentially have 4 hot conductors in your hand right there inside the panel. It's going out, it's doing work, it's got nowhere to go, and the moment you connect that 5th neutral back, it would all flow again. But if you disconnect that neutral bundle, you now could potentially have 4 hot wires in your hand. So I know we went a little bit deeper today than we normally do on the code of the day, but it's a very complex subject, and I hope that I explained it in an easy way. I've got a video called When and Why to Separate Grounds and Neutrals that explains it all in a very easy way to understand with illustrations. Now let's take a look at the funny pick of the day. This is probably the funniest pick I've ever seen. Looks like it's slab on grade, potentially. All tile, right? That might be the dead giveaway. And it looks like somebody forgot to do the slab. Now, riddle me this. Is this going to leave the moment that the inspection's over? It may or may not. Is a homeowner going to leave this in there? And I want to hear your, if you want to leave a funny comment down in the comments below, keep it clean. The best clean, funny comment will win a prize today. We will give you a, if you've never seen my pipe fill keychains, I don't know if I've got them laying around here. Our pipe fill keychain says the most common pipe fill things on them. We'll make sure to send one your way. If you leave the funniest clean comment down in the comments below, I thought this one was hilarious. Now let's head over to Tool Corner. So we have been on a string of wire tugging devices, right? Of course, the sponsor of today's video, StackMax. We've got our normal racking covered with StackMax. And lately we looked at the tub on the right-hand side for pulling MC and NM cable. Then we looked at the Easy Roll wire rack, which I thought was a beast. Tomorrow we're going to look at the Big Easy, right? Today I want us to look at this attachment that you can add on to the normal rack. So we had the initial investment of $142 for this Easy Wire Roll rack, which if you use the coupon code COACH10 at rackyourtiers.com, by following the link in the description below this video, you can save 10% on all these products. But today I want to talk about this Easy add-on arm. And what this ends up looking like is this. So you took the original Easy, which was right here. You can put one roll on it, stretch it out as far as you want on that pipe, as far as that pipe will hold. But what if we want multiple racks here? What's cool about this is it's on like a dolly type system that you can tote around. It says here, get the most out of your Easy Roll wire rack. With the new Easy Roll Multi, this handy add-on extension to the Easy Rolls used by allowing more wire spools to be added, giving it even more functionality and capacity. So I want to note that this is only an add-on if you purchase the original system, and I want to see what you guys think about this. I think it's neat that you can tote it around. You could definitely build yourself a little handle. If you used rigid metal instead of, looks like they're using EMT here. If you use rigid metal for this, you could probably build yourself a pretty cool handle, like with a T, screw a T on, get that thing and build yourself a pretty cool handle so you can actually tote that thing around the job. And listen, if you're pulling wire all over, this thing could be really handy. Tomorrow we're going to look at the Big Easy when you're pulling big reels of wire. And you know, it shows a bunch of single strand here, but you really could, and that white might not be single strand, you really could put 1,000-foot rolls of NM cable on it pretty easily. And I believe that this would help you even on like a residential setting, not only commercial. Now let's get to go know the coach. One place that I'm wanting to travel in my time is Japan. I want to travel to Japan. They take such care of their food and how they prepare things and how they grow things. They are a very interesting culture. We get Wagyu beef from them. We get other delicacies of this world. They have such great care in their fruit. They're just an interesting, cool culture. I would want to visit, do the tour for all the food, eat real Wagyu fresh off the cow, right? And not have to pay all the importing and all the charges that we have if we ever want to have. Occasionally, I'll buy myself like a piece of A5 Japanese, real Wagyu and enjoy it. So I guess for me, it would be I want to travel to Japan. Again, let's talk about the sponsor of today's video. It's StackMax, your ultimate solution for stacking, racking, and storing wire. You can pick up one for 12 gauge and one for 10. They're made right here in the USA, and it's not only going to solve your storage solution problem, it's also an absolute beast as far as durability, but it's going to allow you to stack and rack. I would pick up two. I would pick up one for 12 gauge and one for 10. Put your strandeds in the front, your solids in the back, then you can flip it around if you need, and you'll be able to pull or tug anything you want. You can use it in so many different ways, but this application right here is probably my favorite. You use those little eyelets that are the holes, and you use them to help keep the wire managed. I have pulled probably millions of feet of wire over the years, and I'm telling you, as I'm building my company back, we're getting ready to put some tools back on for video recording purposes, and I want to teach my sons how to wire in this agentic era, and we're getting ready to, so I've got two of these already. I'm going to put them on the truck, get them racked out, and we'll start shooting some in-field videos. Head over to stackmax.com. Don't forget to use the coupon code COACH to save 10%. Today I want to add a little bit of value to you by showing you Tinkercad. So Tinkercad is a very cool program that you can use to teach yourself And you can use, let me make sure you guys can see this well. All right, you can. You can use this to teach yourself or teach your children how circuitry works, whether that be electronics, general circuitry. There's all kinds of cool things. I'm going to show you a couple features today. Now, this is just a 9-volt battery that I've selected, and I'm also going to select an LED. And what's cool is you can learn about the names of the different components. You can also change the color. By clicking on any object, you can actually change the color of the output of the light, which is cool. And then you've got your anode and your cathode. Now, always remember your anode is either going to be the longer one, or in this case, it's bent, and that is going to be your positive terminal. And what's cool is I can just come right here to positive, start drawing my circuit. I'm going to have to go up and around. I hope you guys can see all this. I'll check in a second. Up and around, and then I need to connect to the positive terminal. Let me make sure you guys can see that full. Great, you can. All right, and then I'm gonna have to go here for my negative, and I'm gonna come up. I'm gonna go to the negative terminal. We're gonna come up here and start simulation, and boom, what do we got? A problem. We have way too much current flowing through this thing, don't we? So we actually need to add a resistor. So for this one, we are going to, I found the easiest way for me to add it is to just back off, and I'm going to add it. So I need to add a resistor, so I'm going to come from my positive terminal. I'm going to come up here. I'm going to come over, and just for a simple illustration, I'm going to go ahead and let me back off this. I've not learned all of the tips and tricks on the functions, so boom. But I do know how to make this work. Circuitry. Oh, need to get my lines cleaner, don't I? I wonder if you can drag and drop it. You can. Perfect. I want nice clean lines up and over. Boom. We're going to come over here to the anode. Now we're going to come over here to the cathode. Let's just try to get this in a straight shot here. Boom. We'll drag this out so it's pretty. Real pretty. Now we can turn it on and simulate it. Awesome. Cool. So the light turned on. You can actually take your resistor and adjust it. It's got 1,000 ohms. You can just turn it to regular ohms. And 1 ohm, I've got a dead short, don't I? Now let's add 10 ohms. Simulate it. Oh, still got a dead short, or not enough resistance to constitute the load. And here we go. Boom. Oh, the light bulb turned on, but I have this little caution light. Okay, so you've got 6.7 milliamps, 63.7 milliamps flowing. It's recommended a maximum of 20 for this light bulb. The usable lifetime of the LED may be reduced. And you can set here and add switches, you can add motors, you can add all kind of stuff. The other part I wanted to show you that the kids will also be interested in is this right here. So you can drag and drop. And listen, y'all, this is free, 100% for free. So you can come over here, you can work with shapes. And what's cool, I hope that you guys can see up here in my upper right corner, you can. Up here, I don't know if your boys are into Legos, you can actually turn this into a Lego sketch and then layer it out, and it'll teach them how to build it. So one layer at a time, you can actually work through the layers. So you can build any object you want, and then your boys or girls can deck that thing out in Lego. So I come over here, if I want to build a pair of pliers. Ooh, sweet. So I don't know where I lost my object there. Boom, back me up, baby. All right, so I've lost my object. Anyways, very cool. All right, I got this now. Get this back up in here. I can Lego both of these out. So I can actually take and Lego out any component that I want and work through it. See this, sometimes I was watching a video, sometimes it gets glitchy on some of the fancier stuff, but you can work out the different layers and how to do them. You can also do it in Minecraft mode. So it'll show it in Minecraft, and then there's lots of different applications for this. You can build cool things. You can take text and blow it up. Just wanted to share this with you. Remember, I don't want to lose sight of what this podcast is all about, and it's all about adding value to you. I want to sink so much value into you that you become this brute electrical beast, surpass anything that I could ever do, and go out and do something 10x amazing, and then teach someone else to do 10x amazing, and then it's just this value situation that can't be controlled. So let's not forget why we're here, which is to add value to you. All right, Mindset University. The old Mindset University has now become the Remember Me code of the day. We've done Article 340 for UF cable, 334 for NM, 330 for EMT, 680. Oh, apparently we may have already did 680. Well, we're going to do it again today. 406 for receptacles, 404 for switches. And then again today, just to make sure we drive it home, we're going to do 680 for pools and spas. So remember, Article 680 is going to be your pools and spas. Always stop at the .1 section of any code article to make sure that you're supposed to be in that article. The .1 section is called the scope. So you go to 680.1, and if you don't fit in that narrow scope, and I want you to think about it like the scope of a rifle. If you don't fit inside of that scope of that rifle, if your install situation or scenario falls outside of that scope in 680.1, I want you to move on and go find out where you do fit in. Now, chapters 1 through 4 apply generally across the whole code. But when you get into chapters 5 through 8, depending on what code cycle, 5 through 7, when you get into those chapters, it's going to narrow it in, and you have a scope. Of course, you have a scope in other ones, but they're very broad. These ones are narrow scope. So in 680, it's pools, spas, and the like. And if you don't fit in that scope, and I encourage you today, flip out or search on the internet the scope of 680.1, read it, soak it in, and start to learn what these scopes are all about. Now let's do our history lesson today. And right along with the Tinkercad electronic circuits, we're going to be learning about the transistor. Let's rewind the clock to another giant leap in electrical history. The innovation and rise of the transistor, a tiny device that quietly transformed the entire world. Before the transistor, the world ran on vacuum tubes. These glowing glass cylinders amplified signals and switched currents in early radios, televisions, and the first computers. They worked, but barely. They burned out, got hot, used massive amounts of power, and made machines the size of rooms just to perform simple calculations. By the 1940s, scientists knew that if we were ever going to shrink technology, we needed something smaller, faster, and tougher than a fragile glass tube. Enter Bell Labs, a research powerhouse where some of the brightest minds in science were tinkering with new materials. Their focus was on a strange class of substances called semiconductors, materials that would conduct electricity, but only under certain conditions. In December 1947, three men, John Bardeen, Walter Britton, and William Shockley, which I think is funny, built something extraordinary. It was a simple piece of germanium crystal, a bit of gold foil, and a wire. But when they ran current through it, it did something no one had ever seen before. It amplified an electrical signal without a vacuum tube. That moment marked the birth of the transistor. At first glance, it didn't look like much, a small, odd-looking chunk of metal and a crystal. But what it could do was revolutionary. The transistor could switch currents on and off with incredible speed. It could amplify weak signals into strong ones, and it could do it all while being smaller, cheaper, and cooler than any vacuum tube ever could. This discovery didn't just improve electronics, it completely rewired the world. Within a decade, radios, hearing aids, telephones became portable. Then came the 60s and 70s, and with it, the microchip. Engineers learned that they could etch thousands, then millions of transistors into a single silicone wafer. The result? Computers that once filled an entire building can now sit on a desk. Every smartphone, every computer, every piece of modern technology traces its ancestry back to that moment in Bell Labs. Each transistor, now so small you could fit billions of them on the tip of your finger, is like a microplastic microscopic electro switch, flipping on and off trillions of times a second, powering everything from your digital watch to the most advanced AI systems. It's almost poetic. It's something that you can't even see with the naked eye and holds the key to the entire digital age. The transistor didn't just shrink technology, it supercharged human progress. It launched the information era, transformed communications, and gave us the ability to store, process, and share knowledge on a scale unimaginable a century ago. Electricity gave us power, but the transistor gave us power purpose. It taught electrons to think, and in doing so, it changed what it means to be connected, creative, and a human in this modern world. Now we're going to round out today's lesson with the Small Business Coaching Corner. Listen, you either own a business, you want to own a business, or you may be forced to own a business in this agentic era. So you want to make sure that you soak in as much as good information about small businesses as physically possible. I've been very fortunate to build, scale, sell, and create many successful small businesses, some of them that my children's children will eat food off, Lord willing. On-site estimates. So the question is, and I get it, and the concept is, should I be doing on-site estimates? And let me clarify what I mean. Yes, you need to physically be going to on-site estimates for 99.9 of estimates. That's not what I'm talking about. Now, if you get a set of plans, that's totally different. But I'm talking about when a customer calls, should you physically go out there? That's not what we're talking about today. Yes, you should be going out, selling yourself, selling the job. What I mean is delivering the estimate on-site. Should I give the price right then? Let me talk about a couple of models and some limitations. So one thought is that you can go to a job and in just a few moments give the price right then. I know an HVAC company that the guy would get the information, go out to the car, whether it took 5 or 30 minutes, he would give the estimate right then, delivered in your hand on a piece of paper, handwritten. You can also get a printer in the car. That's fine. That is probably the beast mode way to do it. That's the way to get the most jobs. That's the way to get the least behind. And this is only on smaller jobs that has limitations. Now, he would do it on much larger jobs, of course, but on massive jobs, obviously you can't deliver it then. Some estimates take days, but these are on jobs where it's physically possible that in 5 to 30 minutes you could technically go outside and do it. So it does have limitations, but let me talk about the advantages. And then I want to talk about maybe a hybrid model and how to read the play. And I'll explain what I mean. So let's talk about some advantages of this guy would come in. He did my quote. This is a guy that I know. I've worked with him as far as subcontracted some of his electrical work from him. And he did my personal house. He would come in, do the full tour, do the thing, go out to the car. It took him about 15 minutes and he came back in with a price right then. First off, if I've got a lot of people get 3 estimates, even if they don't tell you they do, they do. Or they've at least been on Google or they've been on ChatGPT at a minimum. With that being said, if you go out and give that estimate and bring it right back to me, and then the other 2 say they'll get it to me in the next 3 to 4 days, and I've already got your price in my hands, listen, we're in the Amazon culture. If someone's got the price and the other 2 people are like, I'll send it to you soon, one guy never sends it and the other one sends it 4 or 5 days later, I promise you the dude, even if his price was higher, that could give them that Amazon instant gratification is likely to get the job above anybody else. We live in an instant gratification world. Buddy, when I want something, I'll drive an hour to go get it. I don't care. They even say they'll deliver it tomorrow. I'll drive and go get it if I really want it now. That's how we all are. Now listen to me. So if you do that, if you'll create that atmosphere right then, it's fresh on their brain, your demeanor, your care, your kindness, your reputation is right there in front of them, and you bring the price in, I'm telling you, you're going to start landing more jobs in the affirmative just because you're the first to strike. Now, let's talk about whether or not you can do it in the moment, and then we'll kind of recap everything. Now, doing it in the moment comes from skill and time in the seat. Some things in life you only get from time in the seat. And what I mean is practice, 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 repetition, repetition, repetition. You can get to a point that you can deliver a lot of estimates. I'm talking while you're in the house. You don't always do that because you want to read the play. But let me talk it through the scenario. If you've taken my free estimating masterclass, YouTube Electrical Code Coach Estimating Masterclass, it's 6 episodes. You will know your day rate and you'll know your minimum hour rate. If you can go in, and this is minimums, and I teach all about that in the series. You can go in, and if I know a job is going to take a day and I know my day rate, I can say, ma'am, this will be about XYZ plus parts. Right there on the spot in moments. I walk around, I do my full estimate like I've taught you before, and you can learn about it in that series, how I physically do the estimate. I come back and say, ma'am, if I think it's 2 days, I can double that price. Ma'am, that'll be about 2,200 plus parts. Then I close my mouth, let her answer, and then if they say send me an estimate, I may go out to the car right then, transition over, give them an estimate right then, a written one, or I may send it on later, gauging that response. let's talk about how to read the play. If it's some customers don't want it right then, they feel like you're going to give them a better, more accurate estimate if you leave and come back, either leave out to the car like we talked about before, or if you send it to them later. And they feel like some people, and if you've done enough estimates, you know what I'm talking about. They don't want it right then. They want you to gather your thoughts, your time, and they want you to send it to them. And if you've never experienced it, once you do, then you'll know what I'm talking about. You can kind of just, with time and experience, you kind of read the type customer. Older customers especially, I find, they're more interested in like a slower process sometimes. They want it, they're used to kind of the old school way where the guy would maybe mail it or come back and bring it back or something like that. Nothing wrong with defaulting to the first one and going out to the car. Amazing if you can get to the point where you can do a certain amount of estimates right there in the moment. If you do the same job over and over, let's say it's a panel change and you're doing indoor only and you know about what it takes every single time, you can give that price while you're right there. The beauty of not going out to the car is there's no gap in atmosphere. When I go into a job and you're competing against me and estimating against me, you better come hungry because I'm coming in, I'm excited about what we're doing. I'm talking about the code, but not too much. I'm walking the customer through, getting excited, listening very intently, paying attention to what they want, helping craft how to make it code compliant without overbogging them with information. Then right there in the moment, while we've got this excitement, I'm often delivering the price right then. Now, sometimes I can. If it's a larger job, I definitely go back. If I read the play, I definitely go back to the office. You can step out to the car if you want to do research on material if you're not comfortable. Especially while you're learning, I highly recommend going out and doing the car method until you get really good. Larger jobs, I'm definitely coming back with a quote, but I want to be the first one to come back with it. If it's small enough to do in the car, I'll go out and do it in the car, come back with a price. If I do have to come back later, then I will go back to the office, crank out the estimate and send it. But I promise you, first come, first serve on these estimates. You'll win more estimates immediately if you just start getting to them quicker. And I'll get it by the end of the week. And the other thing about it too is they don't start to stack up on you. If you've ever done a lot of estimates and you didn't send out the first one, then you went and did 3 more, and then you've got 5 estimates put out, it can feel like a brick around your neck, and it starts to mess with you. And that's why doing them in the moment, it's already done. I literally, if I can do it in the moment or while I'm there, I never have to think about that job ever again until they say yes. I literally never have to if I don't want to. And the reason you want to do that is you want to free up as much bandwidth as possible. I want you to think about it like closing the tabs. You ever been on a browser, on a Chrome browser, then you open up another tab, then you open up, next thing you know, you got 30 tabs and you're like, I don't even know what I'm doing here. That's how life is. If you get your business and you leave one estimate and you're thinking about it because you've not dealt with it, then you leave 2 estimates, then you've got to go visit the men and women on a job, then you got to go to the supply house. You start to have these tabs open in your mind, and next thing you know, by 2:30, you feel like you're going to fall over. And if you do that enough days in a row, you run your business like a wild person. Listen to me, close those tabs by completing the task right then. Go ahead and get the estimate out the door right then. You never have to think about it ever again. And if you're doing a high volume of estimates, you've got to learn tips, tricks, and tactics to keep your sanity. And you need to set up a process, for one, that works all the time, but for 2, that you can hand off to someone else. Because you'll always be everything in your business until you can start handing off some of those items and tasks to someone else. You can't hand it off to somebody else with success unless you've created a system and a process that works consistently, that is judgeable, measurable, and that you can hand off to someone else without it being a bunch of nuances that you did yourself. It's hard to elaborate nuances, and it's hard to expect somebody else to do it. You need to get your thoughts and your process down on paper, down on a screen, then you can transfer those off to someone else unless you want to be doing XYZ function forever. I know a lot of owners love just being the estimator and the business person, and they work themselves up to where they do the estimates and they do the controlling of the money. And that's a great place to be in. But if one day you also want to hand that off, you've got to have systems, processes, and the mental capability and trust to be able to do it. I am the electrical code coach, and my bargain is that this podcast will add value to you, and then you will go out and physically add value to other people. I want you to think about who you can take and add value today. Maybe it's a good thought. Maybe it's an encouraging word. Maybe it's a little inspiration that you've got. Maybe you want to share some of the codes that you've memorized. Think about how you can go out and add value to others. This is the Alpha Phase podcast, but there is one who is the alpha of alphas. It is the most attractive thing there is. He never misses a shot, never misses a beat. He's all powerful, all knowing, omniscient, everywhere all at once. And it's amazing. You know, one attribute that really is attractive to me is his ability to see time. Me and you experience time like a parade, right? How many of y'all love a parade? You get excited, you run down to the edge of the curb, and you see the parade coming. That's kind of the stuff, and you hear it, right? That's kind of the stuff on your calendar, right? You know it's there, it's coming, you're getting excited about the concert, whatever. And when it comes, when the parade comes in front of you, you get to experience it then and at that moment only. That's when you go to the concert, right? It comes off the calendar and becomes real. That's like when the parade is right in front of you. Then the parade goes on, doesn't it? And you can see it off in the distance, and that's kind of like our memories. And that's how we experience time. It's very linear. There's no other way to experience it. But God sees time like this. Imagine taking that same parade and going up in a helicopter and seeing the entire parade from start, middle, finish at all times. And what's more amazing than that, he doesn't just see the whole parade. He also sees the infinite number of paths that you could have taken. Let's imagine that you're looking for a job, and you don't ever get one job offer, do you? Or one job opportunity. They always come in twos. And I feel like some of them are a distraction, and some of them might be blessed either way. But God, I want you to think about this. He doesn't only see if you say yes or no. He sees the infinite number of paths that would come off of either yes or no. That's why sometimes in our prayer life, the answer is no. That's why sometimes this job said no, because that path would not have ended up leading in the result that he's got planned for you. Listen, you're not an accident. You're intentionally designed. Look at everything around us. It's so intricate. And if you look at the great minds of this era, the Sam Altmans, the Elon Musk, the great minds, love them or hate what they do, think, or believe, but watch this now. They all now admit that they believe that something designed this. So if there is a design, that means there's a designer. And I assure you, you'll end up finding, if you look hard enough, that there's only one serious contendant or claimant to designing this thing. And it's an amazing design. From the intricacies of DNA to complex cells to everything in between, to our memory, how it dumps memories we don't need, holds on to ones that we do. It's an amazing, beautiful world that we live in, and I encourage you. So that alpha of alphas that I was talking about, the one that gives me the strength, the grit, the determination to do everything that he's called me to do, or that I dream of or desire, his name is Jesus. Listen, if you need me for anything, you can email me at electricalcodecoach@gmail.com. We'll keep serving you in any way we can. It may morph from this podcast into something else, but as long as I can continue to add value to you, then I feel like that I have done my life's mission and my purpose to continually add value to other people, watch them grow, and then watch that value multiply. I can only do so many things, but if I record it and I add it and impute it and add it onto you and add value to you, then you can go out and add value to others, and then they add value to others. And it's this amazing, never-ending, value-adding, growth, mindset, inspiration web of people, thoughts, ideas, and intentions. I am the Electrical Code Coach.